and share screen. More people trickle in, I'm sure. Clean this up. So we've been talking about teleporting. We have this little device to teleport from that has this teleport to script. It has an array of teleport to devices. It has a particle effect and it has a sound. And we're going to enforce a delay here while we're in the teleport phase. Based on the length of the sound clip, a quarter of the length of the sound clip. And I'm going to, when my player collides with the trigger, this thing has a box collider that's set to be is trigger. It has a rigid body that's is kinematic, and when I collide with that, it checks the tag to see if it's the player that has collided with it. It catches a copy of its animator and rigid body, and it makes this play audio clip that has 3 arguments: the clip, the position, and the volume. It instantiates the little poofer. It puts our character at the teleport to position, and it turns off it makes the rigid body is kinematic, so it can't move, and it turns off the animator so that our character can no longer control it. It turns on the various renderers and colliders of the teleport to device. And then it uses this yield, wait for the delay seconds. On trigger enter has been made into a coroutine by changing the void to I enumerator. And we then wait for this certain amount of seconds with our character frozen, the sound clip playing. And after that wait, we turn the animator back on again. We set the is kinematic back to false. We turn off the shadows and the mesh renderer teleport to components and the capsule collider. So these things all are invisible when we're playing. We can see them in the scene view, but they're all turned off so that they don't clutter up the landscape. Their colliders are off, their renders are off. Whoops, and I just walked into it. And you hear the sound clip playing, which I'm going to mute here so that we don't get clobbered by that. So I think that's where I left off with this little simple one. And I teased you with these higher test ones. One that uses a particle effect that came from the Unity's big particle pack, the big shopping mall of particle effects. And I want to tell you how this works as well. So that effect was called dissolve, I believe. And in this effect, the material gradually disappears with sparks and smoke, and it comes with a script. The particle effect comes with this script that runs the effect. There's not a lot we have to do with this script. This is the spawn effect script that came with that device. And it has a couple of exposed variables. One is the spawn effect time. Another is a pause amount. And then there's this animation curve fade in, and I'll show you how that works in just a minute here. It also uses a custom shader. The object here, the cylinder, has a particle effect on it that's going to do some stuff, and it has embers and smoke. But the material, where's the material? Here's the material, dissolve. It's a custom shader, and it has a number of different properties. We don't need to know anything about this, except that it has a very important one that the curve modifies with time. That's the shader property cutoff. And cutoff is going to determine what level of grayscale the object is visible at. And so in this little shader, we've got we have various properties, the noise, AO, I'm not even sure what that's for. We're not using it. But in the spawn effect, it accesses the particle system in its children. It sets the duration of that particle effect. That's the duration here that's in our particle system editor, and it plays it. So the particle systems are all turned off to begin with, but the script itself, once it's enabled, plays. Now, the update function of this spawn effect is somewhat complex, and I did have to modify it slightly so that I could get it to replay repeatedly. And in order to do that, I had to add this function, reset shader, that we could call to set the shader property back to its 0 value. So this has this little timer, the spawn effect time and the pause, and it tests to see if the particle system is stopped. If it is stopped, it plays it. Otherwise, if the timer has not reached the proper point, it stops it. And then in the update function, it sets the shader property using this fade in evaluate math inverse Lerp, which I'll explain in a little while how that all works. So in teleport 3, the system that's going to control these spawn effects, I've added an array of spawn effects. I have this array of teleport 2s, and I need an array of spawn effects to match that. And I need this array of spawn times as well. Most of this is exactly the same as it was in teleport 2, turning on and off all the different renderers and all that other stuff. But here in the awake function, and if you remember, there's awake and there's start, and they both kind of do similar things. Awake always comes before start. We remember A comes before S, and so awake comes before start. And another subtle difference of awake and start is that start only runs when the script is enabled, whereas awake, it runs when the object comes into existence. And so our spawn effect script is not going to do any of this stuff until it's enabled. So we're going to start off with these spawn effects all turned off. If you look in the teleport 2 here, the spawn effect is turned off. And we'll actually turn it off manually as well. So this start doesn't happen until we turn it on. But we're setting up various properties here. We're getting all of the spawn effect scripts. We're getting all of the spawn effect scripts times, and we're ensuring that they're all turned off by setting them to false. So when we enter the trigger, and I've dotted all the same stuff here for a lot of things here, I have to enable the spawn effect script on the object that I'm going to. So that's the spawns to.enabled equal true. That enables it. That starts the start function of the spawn effect. So it's now running. It's now doing its thing where it samples that curve and gradually turns the material from visible into invisible. It waits the spawn effect time, how long that spawn effect is going to take, and then it turns stuff back on again. And here's where I had to reset the shader in order to be able to do this again, to be able to go into the teleport device a second time. And that's that little function that I added to the spawn effect that came from Unity's particle demo, where I'm just resetting the shader property and I'm setting the timer back to 0, this timer that controls how this all plays. So that's how this whole thing works. And so as I run into these different devices, takes forever. As I run into this device, that script controlling the visibility of the material, and I apologize for the lagginess. It's Unity and Zoom don't play well together, but this material kind of gradually comes into existence, and you can see there's a particle effect going on there. There's sparks and smoke and other stuff happening. Here's that curve that is controlling the fading of the material, this curve that goes from 0 to 1. And I'll show you how we sample from that curve in a little bit here. Another effect that I kind of like was the respawn effect. The respawn effect looks a little different. It has a kind of whirly particle system. And in this case, whoops, I'm still in test 3. Sorry. I want to go to test 4. So this one is a little more complicated because in this case, we're going to put that special custom shader material on Ethan. So Ethan now is the one who's going to come into existence and be all kind of sparkly, and the particle effect whirls around him. And so you can see his visibility coming into existence. And actually, we're not bothering with the cylinder in this case. We're just doing the whirling particle effect and the Ethan appearing kind of gradually, sort of like the teleport or the transporter devices in Star Trek. So this one again uses a custom shader. This custom shader was exactly the same. It had this cutoff that handled the edge and the noise. But in this case, we were doing it differently. In this case, we put the material on the character Ethan rather than on the teleport devices. and the teleport devices are just going to remain invisible, but our Ethan is going to come into existence. The awake function, and I did modify its spawn script as well. It catches the delay, which is 75% of the sound clip length. It turns off the teleport 2 devices. They're off to begin with anyway. And in the on trigger, it catches the spawn effect, the animator, and the character controller. And when we spawn here, instead of just turning off the animator, in this case, I'm going to set forward and turn to 0, which with the Ethan puts him in the idle state. Set the is kinematic to true and control to false. The Ethan character has a control button on its motor that lets us turn off the ability to control it. So Ethan is now in the idle state, and he's enabled. And here I'm setting the cutoff in the shader to be 0. 0 is going to correspond to the beginning of that curve where Ethan is invisible. And as time goes on, it's going to transition to 1, which is where he becomes completely visible. If we look at the Ethan character here, we look at the Ethan body. Here's the spawn effect on the Ethan body. That's the skin mesh renderer that we're going to modify here. And the material is this custom respawn material. And here's the curve that I've picked. I'm going to come visible and then go back a little bit invisible and then become visible again. So I've actually fiddled with the curve here. And if I run this, you can see that the spawn effect time gets set to be a value that's not that default 10, but is well, I got to go in the thing. It gets set to be a quarter of the, or 75% of the spawn time. And here you can see what that material looks like as Ethan comes back into existence. So after we've started it with the reset shader, we wait for a certain number of seconds. I found it was important that I waited just 1 frame here. I wait 4 seconds of 0 seconds is just wait for 1 frame. This let the animations kind of catch up. I'm turning off the animations up here or setting them to be 0. So it takes a little bit of time for those animations to transition appropriately. And so I had to put this little wait in here. I set the spawn effects delay time, enable it. Here's where it starts. And this is where it begins its transition from 0 to 1. Play the audio clip, turn off the animator, wait a certain number of seconds, and then turn the animators back on again, enable control. And here I have to reset the shader back to 1 so that it goes back to the opaque state, which is what I want to have for my character when he's running around the world. Teleport 5 is another of these shaders. And this one, I actually used the same one that I used in Teleport 3, the one that made the cylinder disappear. And I made a reverse respawn, a spawn effect reversed, that in its fade in evaluate, instead of fading in from 0 to 1, which makes the material appeared, I faded from 1 down to 0 by just putting this 1 minus fade instead of fade. And so this spawn reversed effect does the opposite. Instead of the material fading out and disappearing, the material fades in and reappears, which is what I wanted for my character. And again, the material is on Ethan's body. Here's the material, spawn effect reversed. It has a similar fade-in curve. And if I can find the teleport to device and go back into it, you'll see the material fade in over a spawn effect time of 4.47. And then, of course, I have to reset the shader when I'm done with this. So I basically made a copy of spawn effect into spawn effect reversed, changed the class header to be spawn effect reversed, and then put this little 1 minus in fade in. Now, there are a couple of things that we haven't seen before here. One is this inverse Lerp. And we've used Lerp, linear interpolation, that moves from one setting to another over a certain amount of time that is usually manifest in that third parameter, t. And as t goes from 0 to 1, the value returned by the Lerp, which in this case is a float, it's a mathf Lerp, returns a float, changes gradually from A to B as t goes from 0 to 1. Now, inverse Lerp works kind of backwards from this. And with inverse Lerp, we give it a value for its third parameter. And what inverse Lerp does is it returns the value of t, 0 to 1, where that value would appear between A and B. So it tells me the value. It calculates that linear parameter t that produces the interpolant value within the range A to B. So as my timer here, as my timer runs from 0 to spawn effect time, what's being returned by the inverse Lerp is where that timer would appear in the range between 0 and spawn effect time. And so that's going to be a 0 to 1. We then use that in this evaluate function. The exposed variable for this is an animation curve. And that's what appears here in the inspector, the animation curve, which of course we can fiddle with. We can do all kinds of things and make the curve look like we want it to. But the evaluate takes that 0 to 1 produced by the inverse Lerp, and it picks a value off that curve that goes from 0 to 1. So it's going to pick values off that curve. So that's all pretty cool. And these are some tools that I don't think we've seen. But you can see that these animation curves are extremely powerful for controlling how some feature of our game changes with time, which we can do. We can have the value at the beginning, the value at the end. We can have some clock that evaluates where we are in the time. We can inverse Lerp that and get a value of where we are in that range, 0 to whatever. And then we can evaluate our curve at that point, and that gives us then the value of whatever that parameter is. So I'm going to stop sharing here and see if there are any questions. I'll remind you all to type your name into chat. I also want to remind you that the demo draft games are due this Sunday night. This is not the final game that will be graded for content. This is kind of a binary assignment where you hand something in and get credit for it, or you don't hand something in and you don't get credit for it. And I understand that at this point in time, our final games are nowhere near finished, but I need to see whatever it is you've got at this point in time. So you must hand in something. I don't expect it to be complete. We have almost another 2 weeks before the final project is due, but I would like to see what people have at this point in time. If there are some good-looking games that I think are appropriate to show to the class next Friday, I will share screen. I will offer sharing of screen, and you can play your game for people and show it off. So while we're not having an in-person demo day Friday of next week, we will allow people to play their games. If you don't have the hardware to play it with Zoom at the same time, you can make sure that I have a current copy of it and I will attempt to play it for you. I'm not very good at playing some of the hard games that you guys put together here, because you're all much better at playing video games than I am. So any questions about the teleport device or where we're going with demo drafts?
For the demo drafts, would you like anything turned in besides the game package, like any documentation? Or
No.
Just okay.
No, I don't need any. Just the demo draft. I'm just going to look at kind of the state of where you are, and if there's some that look polished enough for us to demo, we'll show them on Friday. And of course, if between Sunday and Friday you polish it enough that you want to, you can send me a new link and I'll look at it again. I'll look at these games as many times as you show them to me. Okay, so let's see. I don't see any questions in chat. So let me go back to sharing then. And let me close this. And while that's chugging, I'll open, whoops, that's not what I wanted. I'll open Black Mirror. All right, so this is kind of similar to what we've been doing with teleporting, but in this case, we're teleporting between scenes. So within that last one, we were teleporting within a scene. We were moving from one place in the world to another place in the world. But in this case, we're going to teleport between scenes. And this works exactly the same way that it did when we loaded a level when we won or lost back with that toy game that we made in assignment 7. So it doesn't use any new machinery, but there are some tricks that we have to apply with this. Now, first of all, let me motivate you for why we want to do this. We might have like a very detailed outdoor scene with a full terrain that has trees and grass and buildings and everything. And we want to enter one of the buildings. And we want the detail to reflect the interior of that building. And it's expensive to have all the junk that we've got in a room, as well as all the junk that we've got in our world. And so we often divide this up into 2 different scenes. One is a scene where we have the interior of the room, and the other is the scene where we have the outside world. And here's an example of this. Here's the outside world. Whoops. Here's the outside world. And this has a terrain. It's got houses on it. It's got horses and trees and fences and all kinds of stuff. But if I look inside one of these buildings, if I can get inside one of these buildings, you see that there's nothing inside the building. And in fact, if we're inside, if we're inside the building, we actually can't see the walls. We can see out through the walls of the building. As I pull back here, I can see the outside, but when I'm in here, I can't see them. And that's because Unity only renders one side of an object. It only renders the front face. And so these walls are just planes. They're only visible from the outside. From the inside, they're not bothering to render because it saves cycles to only render the front face of an object. So then I have here the room, and the room is just a box that contains all of the junk, all of the items that I have in my world, but its walls are also invisible from the outside. We can only see stuff from the inside. The front faces of all those walls are facing in, and so we can only see what's inside the world. And so what I want to be able to do is start off in the outside world here. Unity takes forever when zooming. So here I am in the outside world. It's abysmal frame rate when I'm running Unity. And here's my house that I want to be able to go into. And I walk up to the door and I'm inside the room. And I did this just the same way that we transition from our play scene to our win scene when the game plays. And I've got this door here. I actually have a mirror on the door, which is a whole nother lesson that if you look in the 412 lessons, you can see how to do mirrors, but I can walk back through the door and I'm back in the outside world again. And I actually have another room over here in this house that I can go into. And this is actually the same room, but just decorated a little differently. And you can see over here in the scene view what it is. There's my mirror again, and we're back out in the outside world. So that's the device that we want to set up here in our game. So let me quit this one. And I want to get, which one? Simple TP. So how do we do this? Well, there are a couple of, we're going to use the scene manager, lone scene, new level. So all of that's easy. But when we did our win-lose scenes, and if we happen to have a level up where, we win some level and our character goes to a higher level, in those simple ones, the way we set it up was we had a player in each scene. And when the load scene started, we just took control of that player. But in this scenario, what we want to do is keep our player with us as we go from one scene to another. And this is important because we might have a player that has health and points that are kept track of by the player status script. And so we want to take that information with us, the current score that the player has, what their health status is, what their armaments, abilities, blah, blah, blah are. We want to take that with us. And so when I set this up, the scenes that I'm going to transition to, the outside scene and the two rooms, don't have players in them. They don't have characters that we walk around in. And that's why, if you noticed when I showed you those scenes, it said no camera. It said that there was no camera in that scene. And that's because the camera is with my character. So the trick here is we're going to bring our character with us by declaring it to be indestructible. That is, we're going to mark it as being a don't destroy on load object. This object, when we transition scenes, will not be destroyed. It will persist into the next scene. And we do this in the start or the awake function and of our character, and that means that the character will persist when we load into another scene. And this is why we don't initialize our character in each scene. If we did have a character in each scene, every time that was declared to be don't destroy on load, every time we came back to that scene, we'd get another character, and life would get very confusing. So the trick for this is we need to have one scene that we will never return to. I call it the opening scene. And you can see the opening scene over here in the left-hand side. And the opening scene has our character in it, has our player. And it's got a script that's going to load the first scene where we want to start our game. And you can do this either with an auto load where the start function loads the scene, or you can turn auto load off, in which case the player has to press a key. I prefer this auto load so that the user doesn't actually know that this scene ever exists. They don't even get to see it. They're just immediately immersed in the world. So here I am in this scene. I've got my teleport to character, and the teleport manager is the script that I'll show you here in a second. So I'm going to press play here, and I've got an auto load on, so it just immediately is going to go into the scene. So here I am in that first scene. Now here's where it gets a little complicated. One other really important point is the location your character will appear in the first scene, in that loaded scene, is the same as the position that the character had in the opening scene. So you want to be sure and position your character in the place that you want it to be in the first scene when it appears. So there is some fiddling there to make sure that it doesn't appear like off the grid or inside some object that you don't want it to appear at. So there is a little fiddling there. The opening scene position should be where the physical world coordinates of where you want it to appear in the world. So now that we're in the first scene, we're going to have these portals. And they can be anything. They can be a door. I'm using doors because that makes sense to me. But they can be magic objects or teleporter pads or whatever it is you want. And what I'm going to do is tag all these portal objects as door trigger, a custom tag. So I make a tag door trigger and I put them on all of the objects. And the name of the portal, and remember the names of objects are strings, is going to be the same as the name of the scene that I want to teleport to. You remember with the load level, we had the option of loading by index, its number in the build settings, or we could load it by the string name of the scene. And in this case, we're going to use the portal's name to tell us where that portal is going to take us. So in the teleport manager, I've got, this is the teleport manager. And I need to access my first person character. The standard assets first person character, if I put in a using Unity standard assets characters first person, then I can just directly ask for the first person controller. And I'm calling it FPC here. And these could all be private, but I've left them public so I can see them in the inspector. I'll talk about this in a little while, but I had to modify the standard assets first person controller, and I'll explain why I had to do this in a little bit. But the modification consists of adding a public bool reset that's by default false, and in the update function of the first person controller, I have a test if the reset is ever true, that I do the mouse look init, transform, camera transform, and set reset back to false and return. This, I'll show you, I'll tell you later why I had to do this, but I could find no other solution. So be aware this doesn't work with the default first person controller. You've got to modify it a little bit. So in start, the first thing I'm going to do is set the thing to be don't destroy unload. So the transform game object, that's my player, that has the script teleport manager on it, is going to be set to be don't destroy unload. And incidentally, when I play this over here in the scene here, let me pause this. In the scene here, there's a list of don't destroy unload items that came into this red scene with my little player. So I'm caching the FPC so that I don't have to access it often. In update, I'm going to keep track of what level I'm in, current level. This is basically for debugging purposes. It's a public that's exposed, so this gets the active scene's name. Then in coroutine version of on-controller collider hit, I'm going to test if the object I've hit is a door trigger. Those door triggers, those doors have tags. They have the character controller hits that door trigger, and we catch into where to the name of the object that we've hit, the object game object name. And we catch a copy of the current active scene, the name of the scene that we're in. I could have used that current level here instead if I wanted to, but this is the way I did it. It gets the active scene. And it loads the where to scene. It loads the scene that we're going to. So whatever the name of the object was that we ran into, that's the scene that we're going to load. And so over here, I've got a red door. No, I've got a green door. And so if I run into the green door, it puts me in the green scene. Now, the reason that I had to catch the last level is because I'm going to use that to find the position that I want to put my character in when I get into the new scene. And the way I'm going to do this is I'm going to find a game object with the name last level. Last level was the scene that I transitioned out of when I hit the door. So I know where I came from. I came from last level. And I want to find the door that goes back into that red level. And it takes a while for things to come into existence in Unity. And so I found that it was necessary to wait for a fixed update here. And also I had to do this while the Go object is null, keep looking for it until finally it finds it. So it had to spin here a little while until the world came into existence, because stuff doesn't appear instantly. It comes in some who knows what order. So having found the door that corresponds to that last level, I reset the FPC. And this was the bug that took me hours to fix, trying all kinds of different things. And the only solution I ever came up with was to modify the first person controller. And if anybody can think of a better way to do it, I don't know. The first person controller compulsively oriented its character in the direction it was pointing as it entered the door. So we'd go into the door at an angle, and it would not find, it would leave it at that angle even if the door in the other scene was facing some other direction. And so the only fix for it was that reset. So I set the FPC's reset to true. That triggers its mouse in it, and things work. And then I put my character at the next door's position, 3 units forward from the door, and I give its rotation the same rotation as the door. So this is putting me in front of the door that I just came out of, the door that goes back to the previous level. And it's pointing me out of the door, and it's put me some distance in front of it. You want it to be some distance in front so you don't trigger it and go immediately back in again. And also, the forward vector of the door must face into the scene. And that's why I put doorknobs on my little character. So let's watch this thing in action here. Sorry about that, phone rang. So here I am in the red scene. There's a green door. I walk through the green door. If I look around behind me, there's the red door that I just came out of. I can go back into the red door, and I'm in the red scene. If I walk over here to the blue scene, and it doesn't matter what direction you go into the collider, you just have to trigger it. But I just come out of the blue door. I can go back through the blue door or the red door into the red scene, and I can cycle on around here and go to all of the different scenes like magic. And so that's teleportation among scenes. We have an object that we've collided with. We've tested it and found that its tag is door trigger. We catch a copy of its name, and that's where we're going to. That's the where to. We transition to the scene whose name is that where to, having caught a copy of the last level just before we left. After the transition, we use that last level to find by name a portal, the next door, that leads back into the level we just left, and we position our character 3 units in front of that door, oriented with the same rotation as our found portal. And I'm out of time. I have about 15 more minutes that I'll show you on Monday for these scene transitions, just some interesting examples that I set up, but I don't have time to do that today. So I'm going to end there, stop sharing, answer any questions. Are there any questions? No, I'm going to stop recording.